All right, if you look on the screen, this is what I asked you to do. You'd have to create two constants, one for the minimum grade, which was 0, one for the maximum grade, which was 100. You still have this is exactly the same as before, but then you're going to run this 3 times. Test1 equals parse int. Again, int makes sense because I don't typically give you a 78.2 on a test, but I guess you could. So I changed this to enter first test score, enter second test score, and enter third test score, just so they'd show. You didn't have to do it that way. But then look at the test. It's the same kind of test we just made. While it's not numeric, or it's less than 0, or it's greater than 100, give them an alert saying they put in something out of range and tell them to do it again. So once they hit here, they put in a valid value for test 1. Then we do the same thing for test 2, exactly the same. All I changed in here was the test 1 to test 2. And I changed that. Instead of saying enter first test score, I said second test score. Once we get down to here, then we've got 2 valid test scores. Then we do the same thing for number 3. Enter third test scores. Once we get all of them, we add them up and divide by 3 and print it out. So again, if you look on here, what you're going to see, I run this. So first one, let's leave them what they are, 90, 80, and 70. Their average is an 80. Okay? If we run it again, and I put in junk, we get an error message. If I leave it blank, we get an error message. If I put in a value out of range, we get an error message. If I put in a value out of range too high, we get an error message. That'll happen for all 3 test scores. All right? So let's say you took 3 tests, you got 100, you got a 77, and you got an 88. There's your average. Make sense? So what I'm going to do is I'm going to start going through the material that's in Chapter 3. We've covered a lot of it already, just so you know. We have covered a lot already. So the stuff that we've covered I might gloss over, but I'm not going to spend a lot of time on it. All right, so Chapter 3 starts in the book on page 85. It's about 20 pages, so it's not a very long chapter. If you notice, first, how to code conditional. And you already did that. That's an if statement. That's a condition. Relational operators, that's greater than, less than, greater than or equal to, less than or equal to or not equal to. So we already did those. Logical expressions, we did an or. There's also an and a not. We'll talk about those in a minute. We looked at ifs. We looked at whiles. Well, I'm going to show you a while, a do while, and a for. Then we're going to look at improved, so to speak, miles per gallon program and test program. Finally, the last 5 pages or so talk about arrays. All right, so we're going to hit all that in here. So a conditional expression is if you say if this and you put something in parens, whatever you put in parens has to be true or false. If you say while something and you put that in parens, that has to be true or false. If the if is true, you do what's in the body of the if. If the if is false, you skip it. If the while is true, you do what's in the body in the if. If the while is false, you skip it, period. And if can have an else. Earlier when I showed you this example, if I want to go, let's say, south, I turn left, else I turn right, type of an idea. But you can have it, what we had was an if without an else. You can have that too. You can have an if with a bunch of else ifs. All right? Now, I'm not going to make you do this, but if you really want to learn this stuff, write yourself a big if statement on that test thing that basically says, if the grade was between 90 and 100, then the letter grade is an A. Else if the grade, and keep going down, see if you can do that. If you can do that, you'll probably get a straight A on the next test. All right? And I'm saying that she's not in here, but just so she, if she listens to this, she can hear it. So when you test for equality, 2 equal signs. See that? 1 equal, remember, is assignment. So if I say var age equal 21, that means take 21 and assign it to age. But if I want to say if age equal 21, then it's if parenthesis age equal 21 parenthesis. Does that make sense? Not equal is this, an exclamation point rather, followed by an equal sign. Sometimes they call that bang equal. Sometimes when you hear the exclamation point, it's bang, and that's because of the way that they do it in Unix or Linux. So you know that. Oh yeah. Greater than or equal to, less than or equal to. I'm right in assuming you had those in high school or junior high or something, right? That you know what those mean. Okay. But again, that's a conditional expression. We already talked about the is NaN. We've already seen an example of that. All right. Note, confusing a single equal with a double equals is a common error. In some languages, it'll give you an error and it won't let you go on. Not in this one. It'll just say, oh, you meant to do equal. And guess what? It'll always be true. Your if will always be true if you use a single equal instead of a double equal. The logicals are here. These are the three logicals. You already saw the pipe sign. There's also a double ampersand for and an exclamation point for not. Not true is false, not false is true. Make sense? So not married would mean you're not married. All right? Not married would mean you are married. Okay? I mean, that'd be silly, but you could actually use logic like that. One of the classes that I took when I went for my master's degree, I took a hardware class because I'm hardware stupid. Not that I'm behind. I'm stupid. They gave us, maybe you've seen those, maybe you haven't. It was about this big. It looked like something for a little kid. It was called the Heath Kit. And they had different wires and gates and stuff in there that were simulating a computer. I had to wire this stuff up. Now, that wasn't that bad, but I had to wire it up. Then I had to put it in my car and drive 35 miles to the college. Hope I didn't hit a bad bump on the way, because if I did, they might come out and I'd have to rewire it again once I got there. All right, that wasn't a lot of fun. But I did learn about internally how all this stuff works. So now, when you do this, this is the most lenient right here, the one we just did. So this is the example I've given before, and you tell me if it makes sense, you two. Okay, so I decide I'm going to have a party, and if you want to go to the party, you have to be a student at Rankin, and you have to be in the AWD program. You with me? Okay, so you have to meet both those criteria with an and. So if you're a student at Rankin but you're not in AWD, all right, let's do it this way. I'm going to say that everybody who comes to the party has to be a Rankin student, and you have to be more than 21. Let's put it that way, because we're going to serve booze. I mean, I'm making this up. I'm not having a party, but you get the idea. Okay, so if you go to Rankin but you're not over 21, you can't come. If you're over 21 but you don't go to Rankin, you can't come. The and means they both have to be true. Well, now it's right before the party. Hardly anybody's coming. So now I change it to if you're a Rankin student or you're greater than 21, you can come to the party. Now, if either one of those or both of them are true, you can come to the party. You see the difference between and, where all of it has to be true, and or, when any one is true. And is more restrictive, or is more liberal. Not is just an inverter. Not makes true false, or it makes false true. All right? And that's pretty much what they say down here. Well, I mean, it's like if I said, if you wanted to do this and not this type of an idea. There are uses for it. All right, and they'll make more sense as we go along and you're looking through them. All right, so with a conditional, you can have just an if, you can have an if and an else, and an if with a bunch of else ifs. If you do this, if you look on the screen here, that last else that you see right there, that one is not mandatory. But if you do have an else, it has to go after all of the else ifs. This is where it gets strong, because you can combine things. That's what we just did, right? And what confuses people usually is when to use and when to use or. All right. What if I said, going back to this test thing we just did, wherever it is, I guess it's here. If I made this an and I made this an and, it would be impossible. You couldn't have a non-numeric value and a value that's less than 0 and a value that's greater than 100. You couldn't do that. So usually it's pretty obvious whether you use an or an and when you're looking at it. So an if always has at least an if. It can have one or more else ifs, which are not mandatory. It can have one or more else, or just one else. All right. If you want to put more than one else, it's an else if. All right. I showed you the loop. You already wrote that. We already wrote the while loop. You wrote something that looked like that. If you don't give your way eventually to get out of a while loop, it's called an infinite loop. It means it'll go on forever. If you write this in most programming languages, if you write while, that's a little while, 1 equal 1. Would you agree 1's always going to equal 1? Talk about it. Would you agree with that? Since 1 is going to always equal 1, that's always going to be true. So that'll run forever. And you might say, okay, why would you ever want to do that? Again, I go back to the days when I programmed for the phone company. You always wanted to be able to pick it up at that time and get dial tone. That was 24/7, 365 days a year, right? That was in an infinite loop, the code that made that run. Now, if you put the do on the end, see this? That's a do while. That always runs at least one time. Look at this code in here. You've got while counter less than number of loops. See this? I'm going to grab this code. I'm going to grab every bit of that code and I'm going to copy it to the clipboard. And I'm going to paste it in. Get rid of all that. All right. This says, so counter is equal to 1. Is 1 less than number of loops? So let's say var number of loops equal 10. Okay? So I want to do this 10 times. Now, is 1 less than or equal to 10? Sure it is. So sum of numbers is going to equal that. What this right here does, this thing, it's as though you typed in 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10. That's what you're doing. Now, I'm going to put this in here. Guess if you have to. What if I did this? Is it true? So how many times do you think you'd go through that loop? That's right. If I did this, remember this means add 1 every time. This is the same thing as saying counter equals counter plus 1. What if I did this? What would that do? Yeah, but what would it do? Is 1 ever going to be equal to 11? That's an infinite loop. So normally when you get an infinite loop, you don't give yourself a way to get out of a loop. All right, we'll talk about how you can get out, though, either in here or in the next chapter. Now, let's say that all I want to do is I want to print the numbers from 1 to 10. Are you with me? That's what I want to do. I want to print 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Boom. So I'm going to come in here and I'm going to write this. Var counter equal 1. While counter less than or equal to 10, alert, just counter. Counter, you can either say counter plus plus, or you can say plus plus counter. It doesn't matter. But what that's going to do is that's going to print out 1, then on the next line 2, then on the next line 3, then on the next line 4. Does it make sense? That's what it's going to do. Now, so this is one way of doing it. I could also do this. Do. I'm going to basically grab all of this. So I come through here and I alert counter. Well, up here, let's just say, so let's say I reset it. So var, how about counter 2? And we're going to set that equal to 1. All right, alert counter 2, add 1 to counter 2, and while counter 2 is less than or equal to 10. In fact, let's make that 0. So, no, not good. I'm going to make it 1. So that's going to also print 1 to 10. Does that make sense? There's one more way you can do this. It's called a for loop. All right, I'm going to use, and this one has to have a semicolon at the end. Never, ever put a semicolon at the end of this. All right, it just won't work right if you do that. But I can come in here and say, I'm going to use counter 3. For counter 3 equal 1, counter 3 is less than or equal to 10, plus plus counter 3, alert counter 3. See how there's a little less code? All right. I'm going to run you guys off each one of these. All right. Not that it's a big thing, but you have to be able to understand the different kinds of loops. This loop right here, we couldn't have done this with the programs we did. This is called a counting loop. The for loop, it needs to know exactly how many times it's going through it. With a while or a do while, it doesn't have to know, because you're telling it when to quit. Here you're telling it when it reaches a limit to quit. All right. And they show you all of them in there. So there's the while and the do while. There's the for loop. I think the examples I gave you are better than the ones in the book. All right. So here's 3 programs. We've already done 2 of these, correct? All right. So notice, one or both entries are invalid. Ours is better than theirs. Why? Because they're checking both of them at the same time. You shouldn't do that. You should always check each one individually. It's much better to do that. What if I had 10 values? I could say if value 1 is bad, or value 2 is bad, or value 3 is bad. That's just crummy programming. All right, the way we did it is better. But notice what they've done here. This program will keep going because when you're done, you ask the user if they want to continue, and if they put in a Y for yes, it'll go run it again. We had to basically keep hitting the button to run it again, right? In this, you wouldn't have to. So that part's better than what we wrote. So that's that one. Then there's a future value application. What that says is, if I put $10,000 in the bank and I get an interest rate of 7.5%, which doesn't happen, but if I did and I left it in there for 10 years, I'd double my money. That makes sense? And the code for that, what's important is the JavaScript that's right here. Then finally, they go in and they run that test score. And notice what they're doing in here. They just call it entry. But now you can put in with entry, I can put as many test scores as I want. So that's more powerful than ours is. Okay? All right. And this is new. I'm going to explain this to you. It may not make any sense. All right? It's something that you're going to have to learn to understand over time, just so you know. Now, when I first moved here, I know you don't care, but when I first moved here, I lived in an apartment for 2 years. My wife was still fixing up our house in Illinois and then trying to sell it, which took a year. All right? But I was here by myself. Point is, I lived in an apartment that had 8 units in it. Okay, so just imagine for a second, and maybe this is a good picture, maybe it's not. It's not that important. But, so I was in Unit 1. I'm going to make this a lot smaller because otherwise you won't be able to see it. So I was in, that's a little too small. Oops. That should be big enough. So I was in Unit 1. Let's assume that in Unit 2, the brown family lived. Number 3, the black family lived. I'm just using colors. Number 4, the green family lived. Number 5, the white family lived. Number 6, the red family lived. Number 7, the gold family lived. And in number 8, the orange family lived. Are you with me? That makes sense? All right. Now, let's assume for a second it wasn't, but let's pretend for just a second that the address of the apartment that I lived at was 100 Main Street in Lake St. Louis, Missouri, 63367. Make sense? Okay. So, if somebody sends a mail to me here, do you think it'll go to my right box? I think it probably would. If the mailman, if on each little thing it had a thing with the name of the person who lived there, it probably would. But they'd be better off to put in apartment number 1. That'd be better, right? I guess the house that I have, from what I understand, the one I have in Lake St. Louis now, used to be a rental. I've got an email for like 7 different families. I'm not exaggerating. All right? So the chances are pretty good, either if somebody wrote something, let's say for, I don't know, John Red. Either I'd get it, or the guy'd say, oh, they put the wrong number on, and he'd get it. But probably one of us would get it, right? And in fact, if they even left it out, and if they had names on each one, he'd probably still get it, okay? Why am I even telling you that? Well, imagine that these are people who are in my class. All right, you with me? So there's 8 of them in the class. So we're just pretending this right now. And what I want to do is I want to read in a grade for each one of those students. That make sense? So I can type in var student 1. Let's just we'll call it student 1 grade, and we'll set that equal to 0. All right, I'm going to cheat a little bit here. And I'm going to have student 2, student 3, student 4, student 5, student 6, student 7, student 8. Would you agree? It's kind of like the testing you just wrote, right? So you could write basically while loops 8 times. Would you agree with that? I'm sure you get it to work. I wouldn't even have to give you much time. You could do that. All right? Well, instead of doing that, and there's nothing wrong with doing that except it's more work than you have to do. I'm going to come in here and I'm going to write this. Var students equal, and I'm going to put in this. That's bracket, bracket. That means it's an array. It's something like this. All right? So this right here, if I call, let's just say I call this where I live. What was the name of the darn apartment complex? I don't even remember. Let's just say it was called the Gardens. This would be the Gardens 1, the Gardens 2, the Gardens 3. Does that make sense? But since it's a computer, you start counting with 0. So this would be the Garden 0, 1, 2, 3, 4, 5, 6, 7. Does that make sense? All right, why am I telling you that? Now I can come in here and I can say while, I'm going to just have a thing in here called counter. Var counter, and I'm going to set it equal to 0. All right? So while counter is less than 8, now I'm going to come in here and I'm going to say this. I'm going to have a prompt. Now I'll say grade counter equal, or what do we call that? Students, I'm sorry. Students counter equal prompt parse int prompt enter a grade from 0 to 100. And we'll just default it to 75. I'm just making that up. Doesn't mean anything. All right. Now what I can do is I can say if students counter, and again I'll run this off at the end. So if it's not numeric, or I didn't write any constants, so I'm just going to use 0. Or we again come in and we give our message. So if that's the case, so again we're validating here, we come through here and we say what? We say something like alert, input out of range, re-enter a grade from 0 to 100. And then we again tell them to do this. Now, that's going to handle all 8 grades. So if we've got 8 students looking at it this way, and I'm student 1, my grade will be when it's 0. Browns will be when it's 1. Blacks when it's 2. Greens when it's 3. Whites when it's... Does that make sense? All right, again, I'll run this off as well. But I'm more concerned is, what I'm doing here, I'm going to make this smaller because otherwise it'll look funky on the screen. Does the code make sense? That's what arrays are. So an array, everything, they're like buckets. But everything you put in the bucket has to be the same type of data. All right? JavaScript supports arrays of numbers. It supports arrays of booleans. It supports arrays of strings. Why would we want to use those? Well, I could make this a string array. One for each one of the people who live in that particular apartment. That makes sense? I mean, if we wanted to do that, I'm not saying we would, but I'm saying that's one of the things that we could do. All right, so it'd be an array of names. I could be keeping track of how many students at Rankin it's for Veterans Day. I'm supposed to ask. I don't think you're not a veteran, are you? I was probably too young to be one. All right, but they're going to have a celebration the day after Veterans Day, a free meal, and there's a chance if you're a veteran, I guess, that you can put in for they're having a contest or giving away an iPad. All right, but you have to meet that criteria. All right. So an array is an object that contains one or more items. Each item, like each name we had, is called an array element. And they start at 0. Now, there's 2 ways that you can create an array. I showed you the easy way. To me, that makes the most sense. You can also do this. And if I want to, when I create an array, I can give it a size. Now, remember I told you how, in many ways, JavaScript is very forgiving? It's also way too nice in this aspect. JavaScript and PHP are 2 of the only languages I know of that when you create an array, you can make it bigger as the program goes. So it's like if they decided that they were going to come in and add 8 more units here, if I did it in any language but JavaScript or PHP, I'd have to make a new array that would be a size 16. But in JavaScript, you can just keep adding, and it'll make the array one bigger, then one bigger, then one bigger. So you can make it as big as you want it to be. All right? Then they show you how to add values to an array. You can add them one at a time, or the way that we did it, where we did it inside of a loop, which is much easier. I think you'd agree with that. All right. Again, for loops especially are meant to be used with arrays, because with an array, you always know at any time what the size is. Even if you add more to it, it's always got a size. So you can say from 0 to whatever that size is. Right? And that's what they're showing you right here. Now, that's just an introduction. So they rewrite the test scores application, and they rewrite it using an array. See that? All right. So what I'm going to ask that you do, I'll give her till tomorrow, so hopefully she'll feel better then, but I'm going to ask that you key in the test score one with an array in it, all right, and the future value one, which we didn't do yet. So I'm going to ask that you do those too. All right, so there's the code for that one is on page 99, and the code for the other one is on page 107. You can use the same interface you've been using with just a button on it, but have it call those. Does that make sense? You get those two done, get them into me by tomorrow at the end of class, 25 more points. All right, and hopefully she'll feel better tomorrow, and I can explain that to her. All right, tomorrow, like I said, when you come in here, we're going to grab or do a bunch of iterations of this payroll example, and we do that. It'll probably be the first 1 to 2 hours. The rest of the period will be lab. Wait a minute, tomorrow is Friday. We won't do it tomorrow. Monday we'll do that. Tomorrow's lab all period. So you should have plenty of time. She should have plenty of time to finish this. Questions? All right.